Hi, here's a short video. Is this an equation, function, or an expression? Well, if we look at number one, x squared minus 2x adds 6. Well, this is an expression in x. It has three terms, x squared minus 2x and a constant term 6. Number two is a quadratic equation, simply because it has an equal sign. And this is a quadratic equation in x squared minus 2x adds 6. Number three, well, this is a function, f, and it shows it, uses the notation of mapping from x, which maps onto x squared minus 2x adds 6. And what makes it a function also is that it defines its domain. X is in the set of real numbers. So you can choose any number that is a real number as input to the function f. And number four, it's also a function, just a different way of writing, a different notation of writing a function. F of x, we say, is equivalent to x squared minus 2x at 6, where x is in the set of real numbers. Remember that the set of real numbers is anywhere on the number line, whether it be a whole number, fraction, or decimal, positive or negative number. Hi, let's have a look at modeling change. These are the questions we'll be looking at. How fast is something changing? Is it increasing or decreasing? Does it stop temporarily or permanently? And how could we describe this change using an equation? For that, we use the process called differentiation. And that's a mathematical process used to analyze the rate at which variables change and whether that change is an increase or decrease, or whether the change stops altogether. And for that, we're going to look at the gradient of a line. That represents a linear function, and that relates the dependent variable y to the independent variable x. And it's shown on this graph here. For this equation, y is equal to mx plus c. We have the skater going up the slope. And as he moves from one location to another, there are changes of the x values and also changes of the y values. The gradient is a measure of how fast the variable y is changing as the variable x changes. A large gradient or a steep slope means a rapid change of y with respect to x. A small gradient means a slow change of y with respect to x. Thanks for watching this video. My name is Alistair.
What is the velocity of the wood after 5 seconds? Well, now we have when t is equal to 5, we have our velocity is equal to f dash of 5, which is equal to 14 times 5, which is equal to 70 meters per second. So remember, our velocity function v is equal to 14t. After we differentiated the position with respect to time, we have the velocity, which is 14t. Hi, a piece of wood dropped from rest has position s equal to 7t squared meters below its initial point after t seconds. what is the velocity of the wood at time t? We know our position function s is equal to f of t, and this is equal to 7t squared. So if we differentiate the position with respect to time, we can get our velocity. So v is equal to the derivative of f, which gives us 14t. So now that we know our velocity function is 14t, we'll be able to calculate the velocity at any time. At what time does the piece of wood have a velocity of 21 meters per second? We know when v is equal to 21, then we have 21 is equal to 14t. Bear in mind we did calculate our velocity function as v is equal to 14t. And our solution here, t, is 21 over 14, which gives us 1.5 seconds. So hence, the piece of wood has velocity of 21 meters per second. Just write this clearly here. So t is equal to 21 over 14, which is equal to 1.5 seconds. And to summarize, the piece of wood has velocity of 21 meters per second after 1.5 seconds. Thanks for watching this video. My name is Alistair, and I'll see you on the next one. Bye for now.
Hi, today we'll talk about integration and modeling, and we'll address two questions. How does a change accumulate? And for this, we'll use the process of integration. And secondly, how can a change be described by an equation or function? And for this question, we'll solve that equation using a differential equation. Let's compare differentiation with integration. Differentiation deals with instantaneous values, and here we use instantaneous velocity of a car, and that's calculated by differentiating its position function with respect to time. So we move from the position function to achieve the velocity. Whereas in integration, we want to know how much can we deduce about the car's position based on the knowledge of its velocity function. So we start with a velocity function to achieve the car's position. And here what it looks like in symbols. We have the velocity function v is described as ds dt, which is equal to 6t. And the question is, what is an expression for s such that ds dt is equal to 6t, the differential equation? And that achieves the position function s, which is equal to 3t squared. My name is Alistair. Thank you for watching. Hi, today we'll address the questions of whether the change is increasing or decreasing, or both. And also we'll look at how we describe this change by an equation or function. A major application of differentiation is optimization.
and that's to find the optimum value of a function, or in other words, the highest or lowest value. In a mathematical modeling context, that's the best way of achieving a practical outcome. For example, maximization of profit if you run a business, or minimization of resource expenditure. Optimization is the process of finding the greatest and least values. And the greatest or least values attained by a function on an interval is what we call the optimum values. In this graph, we have our interval spanning between -4 and +4. On the first half left, we have the function increasing to a maximum value of 16, decreasing to a minimum value of -16, and then increasing again. This function describes a cubic equation. Remember, the function describes an equation. The equation describes the change in values between x with respect to the y values. This is mathematical modeling. My name is Alistair Harris. Thanks for watching.